Right. So the key question in this entire module is about what determines GDP. But as you're going to see later, essentially, so this is going to determine by demand versus supply. Okay. But we have to go like slowly or like step by step to understand what the terms, like how supply and demand. Right? And here, so the demand and supply is a little bit different from what we discussed earlier. Because here, so this is about aggregate economy. We are not talking about demand and supply for, say, for example, a bottle of water. We are going to talk about supply of demand of our entire economy. So then, so the way we proceed is a bit different. So we are going to start with demand. And in terms of demand, how we're going to start essentially is coming from this equation. Y equal to C plus I plus G plus NX. Okay, so when we start with demand, we are going to start from this equation. And this also should be intuitive. Okay, why? So this is the equation we are going to rely on to understand demand. Why? Because this equation is one of the three approaches to understand GDP. And this equation focuses on expenditure approach. And the expenditure is spending, and spending essentially is what? It's just demand, right? So that's where we start. So in this chapter and in the next chapter, we are going to focus on the demand. All right, but there's the demand. When we study demand, we are going to take many things as given. That's what we did, like similar in microeconomics. So we are going to take price as given. So we are going to take the supply as given. Right, so that's how we approach. But in order to understand, so what determines demand? Okay, and in order to understand this equation, so we are going to study some macroeconomic relations. So that's the focus of this chapter. Okay, so essentially, we are going to study some macroeconomic relationship, particularly C and I. And the reason why I focus on these two is because, yes, there are 4 items, but we are going to simplify, or we focus on the most important things, and particularly C. Why I say C is important, so you probably have seen before, or you remember what we have seen before. C as a ratio of GDP is close to 70%, right? So in terms of magnitude, it's very, very important, right? So, and then in this chapter, we're going to focus on the macroeconomic relationship regarding to C. But because it's like a relationship, then meaning there's some other variables. Okay, what are the other variables? So we're going to see how C is going to vary with income. But as you're going to see later, income essentially is also GDP. Remember, so GDP, we have 3 ways to look at, right? So we look at spending, which is demand. We look at a product, which essentially is supply. And we also look at income. Okay, that's kind of a bridge. All right. Okay, and then so in this chapter, so what are we going to do? So we are going to look at essentially how consumption and investment is going to determine or varies with some key parameters or key variables. Okay. In order to understand these things, we're going to start with a multiplier. So that's a roadmap of this chapter. To summarize, so this is the beginning for us to understand what determines GDP, and we focus on the demand side. All right. So as we have seen from the flow chart, so diagram. Okay, so we understand, we already knew households and firms are mutually interdependent, right? So they were connected through 2 markets. One market is the goods market. The other market is factor market, right? So they are interdependent, right? And then, so they're supposed to have like a chain reaction. What is a chain reaction? So I spent $1. So that goes to the goods market, right? And then, so this $1 is become to somebody else's income, right? And then the somebody else, they're going to have additional $1. They must do something. So that's a chain reaction. Yeah, and then, so this chain reaction is going to characterized by this multiplier. And this multiplier is going to be very important for us to understand how the consumption and income link together, or so what determine the macroeconomic relations as we are interested in. All right. To help you to understand their interconnection, interdependence, and to help you understand the multiplier, let's look at an example. If UNMC decide to build a new hospital, and the total cost for this new hospital is $1 billion. Now I'm asking you, how much does this affect the local economy? Now to simplify, let's say every person hired for this project are local, okay, including architects, including those workers, okay, or everything. This is to simplify, right? But certainty, so you don't need to simplify. Says, okay, so what is the impact on the U.S. economy? Well, it's a little bit too broad. Let's just focus on the Omaha, simpler. Right? And furthermore, we also assume all the material we acquired locally. But again, this is for simplification. Right? Now, how would that affect the local economy? What do you think? Let me give you 1 minute. You can just discuss with someone, or you think about yourself. So if UMC decide to spend $1 billion to build a hospital, hire everyone from local, and purchase material from local, and what will be the impact on the local economy? So that's a question. Okay, give you maybe 1 minute to think about, and then so we just go through together. So what would happen? Immediately, so there's going to $1 billion of additional spending, right? So either show up as a wage, or show up as a purchase of material, right? And then so the total demand or total consumption or whatever, so the GDP is going to increase by $1 billion. Will that be the end of the story? No. What happened next? Civic example, so I'm one of the architects. I was paid for $1 million to design the hospital. Out of this 1 billion. And then so I have additional $1 million, right? What am I going to do with this $1 million? Spend, right? So this is like a natural response. Okay, how much am I going to spend? So that's what we're going to discuss, right? Okay, so if I civic number, if I decide to spend half, that's a reasonable number, right? So $500, you can buy a decent house today, right? So like a couple of years ago, you can buy a mansion, but not anymore. So I can buy a decent house, or like some of my neighbor did, so they have some additions to their house. And then, so you can see there's a chain reaction. I spent $500,000, and then somebody else, that's kind of independent of this 1 billion spending or this 1 billion hospital, right? Somebody else have $500,000 of income, and then someone else is going to do additional spending. So you can see there's a chain reaction. But hopefully you can see, so the net impact or the magnitude of this chain reaction crucially depending on one factor, which is what? How much I'm going to spend out of the income I receive, right? So this coming up in next slide. So the crucial parameter is marginal propensity to consume, short for MPC. So essentially just measuring in the margin, how much I'm willing to spend. In the margin, if I have $1 additional, how much I'm going to spend, right? So this delta, this triangle actually is pronounced as delta. This is coming from Greek letter. Okay? This delta change in consumer spending divided by change in disposable income. So essentially, for each dollar additional income I have, how much I'm willing to spend, right? So this is MPC. Give you an example. So if my income goes up by $10, I'm going to spend $6, then my MPC is 0.6 or 60%, right? But remember, so probably just hide this for now. For each dollar, either I spend or I save, right? And then immediately we get an interesting equation, which is, so maybe I can derive a little bit, okay? So for each dollar or change in disposable income, that's called DI. So what you can do, you can either consume, change in consumption. What else you can do? You can change in saving. Does that make sense? Okay. So someone may say, okay, what happens? So if my dollar, I lost my dollar, how would you count? And then so the easier way to fit into this equation is this $1 you consume. Does that make sense? Okay, just simplify, right? Okay. Or someone say, okay, what happens if I donate? Again, that is considered as a consumption, right? So each dollar you either consume or you save. Now, if we divide by change in disposable income on both sides, this equation still holds, right? But now what are we getting? Left hand side is 1, right hand side, what it is? This is MPC, right? And then so this term we called MPS, marginal propensity to save. Okay. So let me erase and then see so what we have in these slides. So that's it, then I'm here. So this essentially just tells you MPC plus MPS equal to 1. And it comes from the fact each dollar of additional income, you either consume or you spend, right? So MPC is going to give us multiplier effect. What is the multiplier effect? Look at examples. If investment spending rises by 100 billion, okay? So remember, this is aggregate economy. So we talk about the total economy. So that's why you see this huge number. And this $1 billion in reality usually show up in different forms. Say, for example, the government decide to renovate infrastructure. The other day I was watching news. I heard currently, so in the United States, there are 20,000 bridges under renovation. That's a lot, right? So that's kind of explains so what this 100 billion means. All right. So now we are going to see so how this increase in investment spending translate into total increase in GDP or in expenditure. Right. So things go as follows. So the government spent 100 billion to say them renovate highway system or bridge across the United States. And these 100 billions becomes spending first and then becomes income, somebody else. Does it make sense? because you need to hire workers, right? They need to purchase materials, right? And the money goes to whoever work for those projects, whoever provide material to those projects. All right, and then this $100 billion becomes income of those recipients. Okay, so and then, so for those whoever receive those incomes, what they're gonna do? What they're gonna do? They're gonna spend, right? So they have different spending. Maybe go to restaurant, maybe pay their mortgage, maybe go for a vacation, right? Or maybe just pay for the kids' college. So how much they're gonna spend, like we just studied in the previous slides, it's gonna depend on MPC, right? So the total spending is gonna be this number. Does it make sense? Because in the total, there's 100 billion increase in income. And then collectively, they're gonna spend a fraction from this 100 billion. Right? Which is MPC times 100 billion. Now this step won't stop here. This is going to keep moving, right? And the next step is going to be, so this income for the next round. And then you multiply this MPC, right? And then so you can see collectively, what are we going to have? Collectively, we are going to have the following, which is given by this equation. But essentially, this is 100 plus MPC times 100 plus MPC times MPC times 100, right? So this one, this goes here, this MPC goes here, this MPC square goes here. This is the first round, immediately you spend and it becomes income. This is the second round, right? So this spending becomes the income. And then so people spend a fraction. Now third, so this entire thing becomes income. Right? And then they spend a fraction. And this process keep moving. Does it make sense? Okay. And then for students familiar with this calculus or this algebra, and you immediately know the following. So the term inside this parenthesis is going to give you this number or this formula, right? But remember, so this is only true when MPC is between 0 and 1, right? But naturally, MPC must usually is between 0 and 1. By the way, so what does that mean? If MPC goes to 0, what does that mean? Again, this is also useful to understand some extreme case. Okay. First of all, this is a multiplier. Now let's understand two extreme cases. MPC equal to 0, MPC equal to 1. What this means and what that implies to the multiplier. If MPC equal to 0, yes? Right, yes, please. Right, so MPC means you don't spend at all. If you don't spend at all, actually this implies a multiplier equal to 1. Multiplier equal to 1. No, I'm saying if MPC equal to 0. If MPC equal to 0, and then so by the way, this is a multiplier, and then multiplier equal to 1. Equal to 1. What this means? Means the entire thing is going to collapse after the first round, right? Because after the first round, no one is going to spend. Does that make sense? So now go to another extreme. MPC equal to 1. What does that mean? You spend all your money. Now you can see this thing is going to move perpetually, right? It never stops. And then so this multipliers goes to what? Goes to infinity. Right? Because 1 divided by 0 equal to infinity. And then why is infinity? Because, okay, so you have 100 billion at the beginning, and the next guy is going to spend another 100 billion. And the next guy spend another 100 billion. And then the next guy spend 100 billion. And this process never stops. Right? Because this help you to understand so how this MPC link with the multiplier, or how multiplier comes out, right? Now we have a quick discussion. So I'm going to give you 1 minute to work through. Just suppose the MPS is 0.2, and suppose investment spending increased by $200. They ask you, so what would be impact on the overall increase in real GDP? Okay, I'm going to give you 1 minute to think about. So I guess maybe we can use the example to understand, right? So say, for example, this $200 was initially decided to buy a pad, like a Samsung pad, right? So probably that's what you can buy with $200. You cannot buy an iPad, no? Or maybe used, right? So if for example, you buy like Samsung, $200, okay? And then so immediately, so the GDP is going to increase by $200. Why? Does that make sense? Because you're going to spend, and Samsung is going to produce one additional tablet, right? That's what they call tablet, right? Okay. Does it make sense? Because otherwise, if you don't spend this 200, and usually, so if Samsung already produced this tablet, and then so what happened? They're going to put in the inventory, right? And usually it goes to investment, right? Okay, so that's a different story. Okay, so anyway, so you pay $200, you buy a Samsung tablet, and then so Samsung have $200 additional income, right? And usually this $200 income goes to their workers or their third-party suppliers, right? To simplify, say for example, this $200 goes to worker. And also further simplify, this goes to one particular worker. All right, so just like a lucky employees. So what is lucky employees going to do with $200? Remember, this is additional. What they're going to do? So they're going to spend how much? It's 0.2 or 0.8? 0.8, right? So that just means, let me write down. So first you have $200. And then, so this employee is going to have $200 and is going to spend 0.8 times 200. Okay. And we need to specify what she or he is going to spend. Let's say, for example, so she is going to spend this $160 on a Halloween party, right? So it's either just go to Villa's pumpkin patch. Have everyone been there? I was surprised it's so expensive for the tickets. So we see what with the wonders but seriously expensive. So with $160, so you can only have like 3 or 4 guests, right? Okay. And then so immediately Vita's pumpkin patch, they're gonna have additional $160 of income. They go to their employees, right? And then their employees go to another round of spending, right? So they buy them a meal. Oh, by the way, so these terms come from here, right? So this is essentially what this in our example. This is employee of Vita's pumpkin patch. They are going to spend 0.8, right? So they're going to buy themselves a meal, and so on and so forth, right? And this process keep moving, but the net impact is going to be 1/1 minus 0.8 times 200, which is equal to $1,000, right? So this is multiplier. Okay. So this is how we get, right? This is the initial increase. Second round, right? Third round was coming from here. This entire thing as income, and you have MPC. And similarly, so you have these coming from here, and you have MPC. All right, and you add them together, you have this total number. All right, this is clear. So this is called multiplier, right? $1 spending is going to have more than $1 impact on the total spending or total income, right? Question so far? No? Okay, so now we are going to look at this autonomous change in aggregate spending and how this link with multiplier. Essentially, we are going to have this formula, okay? Changes in total GDP equal to, so this is multiplier, times changes in autonomous spending, or essentially some increase in spending, right? But essentially here, so this is just give us the multiplier. If the spending initially increased by $1, what will be the net impact on total GDP? All right. Now let's look at a practice question. This question asks you, holding everything else constant in the economy, what happens if MPS increase? How would that affect the multiplier? So there are two things we need to know, right? Number one equal to MPC plus MPS. 2 multiplier equal to 1 over, right? So if this number increase, means this number decrease. Okay, if this number decrease and then the entire things increase, but then the multiplier is going to decrease. Does that make sense? So this is just very mathematically derived, but we can also think this in terms of economics and intuitive. So how you think this intuitive? So MPS increase meaning what? For each dollar you have, you save more, meaning you spend less. If you spend less, and then this multiplier naturally is smaller, because each round people is going to spend less out of the income they have. And this chain rule is going to go getting smaller. Right? Okay. So the answer is A. Okay. Now we are going to look at a case study to understand this multiplier. And actually, this multiplier has a broader impact to our aggregate economy. What we look at here is a particular time period, 2006 to 2010. What happened during that time period? Does anyone know? For our macro economy, for the US economy, what happened? What is the big things happened during that time period? Has everyone heard about this housing market collapse? 2008, right? Okay, very good. So housing market collapse. It first show up here. So we look at the construction sector. The housing market collapse, and then naturally, what happened? People losing jobs, right? Okay. And then so here we comparing two sectors, sand state and the non-sand state. And what's the difference? So sand state here includes Florida, Arizona, California, and Nevada. What are they in common? And why they was called sand state, and why we grew them together? Can you tell any sign from there? Anything they are sharing? Any particular things they are in common? What about their weather? Warm or cold? Warm, right? So those are states they are warm, they have beaches, right? So that's why they call like sand state. So essentially, this is a place people willing to spend for their retirement, people willing to spend for their vacation, and certainly the housing demand is high. All right, but then so if the housing market collapse, and those sand states, they suffer more because usually there's lots of investment or lots of excessive investment, like people buy second home house or vacation house, right? If the market collapse, and then those states is going to suffer more. Actually, this show up by the difference in employment. Does it make sense? So this is the first step. Now, where does the multiplier show up? The multiplier actually show up here. Show up at non-construction sector. If there's no multiplier, and then so whatever happened in construction sector won't have impact on non-construction sector, right? But why you see a change in non-construction sector, or why does non-construction sector also suffering job loss? It's because so those people work in construction because of the housing market slump. Those people lost their job, lose their income, right? And then they cannot spend as before. So that's going to have impact on non-construction. But it's certainly, so the impact is different depending on whether you are in sand state or non-sand state, right? And the difference largely reflects by the difference here, right? So that's a case study to show you the existence of multiplier, because in one sector, people lose their job, and then they lose their income, and then they're going to spend less, and that's going to translate into other sector, right? So this is what we learned from this particular case study, okay? Multiplier is real. Now, so we are ready to look at the first macroeconomic relation, which is consumer spending, or how consumer spending, depending on some particular aggregate variable. Households, they spend, there are many things matter to their spending. Here we're going to focus on how household spending depend on income. Okay, depending on income. And their relationship usually is going to like this graph shows. What is this graph? So in this graph, so we take data from our actual economy. And so on the horizontal line, you have current disposable income. Vertical line, you have consumer spending. And each dot is going to represent a household. Okay, each dot represent one household in the United States in a particular year. And here, what we look at is 2013. In 2013, so basically this graph just tells you if some households has a disposable income of roughly 45,000, and then roughly their spending is close to 41 or 42 something. All right. And similarly, you can look at some high income households. If their household's disposable income is 160,000, and then their spending goes close to 100,000, right? So this is where this graph coming from. Now, by looking at this graph, what patterns do you spot? What pattern do you spot by looking at this graph? Yes. Very good. So the more income you have, the more you spend. Now, in other words, consumer spending is positively correlated with your income. This is number one. Number two, the number two thing is a little bit subtle or it's a little bit hidden. Let me give you a hint. So if you connect those dots, first of all, this is a positive. This slope is positive. This refers to what you just said, what the student says. So the more income you have, more spending you have. Now, what happened to the slope of this curve? Is constant or is changing? It's roughly constant, right? Roughly constant. Meaning regardless who you are, so you're going to spend a fraction of your additional income. As a matter of fact, this slope actually coming from MPC. All right, so that's linked to what we discussed in previous slides, why we start MPC. Because MPC is going to be a good thing to characterize the consumer spending behavior. Right. Okay, so based on those data, and we are going to have a consumption function. So this is essentially an equation show how individual consumer spending varies with disposable income. And more specifically, so we have C on the left-hand side, which is consumer spending. On the right-hand side, consumer spending is going to depend on the following things. First, your disposable income. And then it's MPC. But what is A? A, we call, here it goes. A is a constant. And it's called autonomous consumer spending. And then furthermore, A is the amount you're going to spend if YD equal to 0. And how we interpret this A. So this is essentially something very basic, very necessary for you to survive, for you to live, right? You can think about this like a poverty line. The consumption you have to carry, even though you live under poverty. Does it make sense? Okay. But certainly this A change with the location you live, and A can also change over time, right? Okay. So now we are going to run a few algebra. to kind of understand this a little bit better. So MPC is defined as change in consumption as a ratio of change in disposable income. Now, if we multiply both sides, we get this equation, right? Very straightforward. This just means if disposable income increase by $1, and the consumption will go up by MPC dollar, right? So this is what this means. Now, before we just move forward, let's just look at a practice question. Suppose Sue's disposable income is 10,000. If her disposable income 10,000, she spent 8,000. Now, if her disposable income increased to 20,000, she spent 14,000. And then the question asks you, what is her autonomous spending? And then what is her MPS? Just remind you, so we just learned this consumption function C equal to A plus MPC times YD. So basically, we have two things to determine. One is A, the other is MPC. Right? First, let's look at what is MPC. So MPC, right? Now then here, so what information we have? So consumption increased from 8,000 to 14,000. When income increased from 10,000 to 20,000. And then we just plug in here, right? So 10K, sorry, 14K minus 80K divided by 20K minus 10K. Right? So that's give you 0.6. But that immediately means MPS equal to 0.4, right? Does that make sense? Are you with me? Because 1 minus 0.6 equal to 0.4. Okay, so this is MPC. Now, how we are going to find A? So basically, you're going to plug this number inside. So basically, so you have 8K equal to A plus 0.6 times 10K. Okay, why we have this equation? It's because this equation characterizes the consumer's behavior, right? And then this must be hold true for any level of income she has. And in particular, so if she has 10K of income, she's going to spend 80K. And similarly, so she has 20K income, she's going to spend 14K. You can use either number to back out A. Now from here, you can simply solve for A, right? Because 8K and this gives you 6K. So the immediately A equal to what? 2,000, right? Does that make sense? So the answer is D. But alternatively, what you can do, alternatively, you can say 14K equal to A plus 0.6 times 20K. Right? Are you with me? And then so immediately you're going to get A equal to 2K, right? Because 0.6 times 20 equal to 12. 14 minus 12 equal to 2. The same answer. By construction, it must be the same answer because their consumption behavior is a linear function. Right? Okay. So the answer is D, right? Autonomous spending is the autonomous spending is 2K and the multiplier. Sorry, so the MPC is 0.6 implies a MPS equal to 0.4. Okay. Now this is the consumption function, but it's essentially coming from our observation of data. And then we have some this postulation, we have some this hypothesis, right? And what this hypothesis essentially just says, okay, so the consumption is depending on your disposable income and also depending on your MPC. Okay, and then in a very abstract way, so C is going to positively correlate with your disposable income. Furthermore, the slope of this curve is given by MPC. Right? So how we calculate curve? How we calculate the slope of the curve? So the change in the vertical line divided by change in horizontal line. Right? But that's equal to MPC. Okay? Slope equal to MPC. And C equal to A plus MPC times YD. And A is goes to here. Oh, sorry. A goes to here. Right? So we call it autonomous spending. So this is the amount you must spend, even your disposable income equal to 0. All right? And someone may just wondering, so if I have a disposable income equal to 0, how would I spend? Where's spending coming from? What do you think? So usually this either coming from borrowing or coming from some social program, like like food stamps, right? What we call it usually, so that's what we call the social insurance. Okay. Next question. How well do the data fit the theory? So we just have a series. So just remember, this is a series. But this series says, so your consumption is a function, actually it's a linear function of disposable income. Right? Now we are going to test the theory by comparing the theory, which is represented by this line, with the data or with reality, which is represented by those dots. Okay, we have 5 dots, but potentially we have millions of dots. By comparing these two, what do we learn? What we can say by looking at this graph? So essentially, the theory predicts the reality very well, right? Or in other words, they fit very well, right? Because this curve, this line almost perfectly match with those dots, right? So now we are going to look at aggregate, but this is essentially just move from individual to aggregate, just sum together. And we are going to have almost identical functional form. Except now we move from individual, because before we have lowercase a to capital A, lowercase yd to capital YD, meaning aggregate. Okay, and similar C will change to aggregate. Right. So this aggregate consumption function is pretty much the same as the individual consumption function as we discussed. The key things is that it's a straight line. The slope equal to MPC. Those are the key things. Right. Now another practice question. So let me write down the information in a simple way. So let's say, for example, we write here C YD. Okay, when disposable income equal to 0, consumption equal to 5,000 is 1. When disposable income increase from 300 to 400, or if there's change equal to 100, and then the change in C equal to 70. So this implies what? MPC equal to, what is the MPC? Huh? 0.7, right? So thank you. Now the consumption function equal to A plus 0.7 times YD. The only thing unknown is A, right? And how we are going to find out A? So use this information, right? So you just plug in 5,000 equal to A plus 0.7 times 0. Implies A equal to 5,000. Okay, and then immediately, which one is correct? C. This is clear. So essentially, there are two things you need to determine. One is MPC, the other is autonomous spending, right? MPC coming from what? How you change your consumption when your income increase. That's how we determine MPC. And A is determined by what? You just find out a particular point, plug into the equation, and that's going to help us to determine the only unknown, which is autonomous spending. Right? Okay. So sometimes the aggregate consumption function may shift. Okay. There are two possibilities. If shift up means what? There's increase. If shift down, it means a decrease. But you may wonder what can cause an increase of aggregate consumption. Usually, it comes when we have a good expectation or high expectation about the future. And then you have confidence to spend. On the other hand, so if you worry about the future, what's going to happen? You want to decrease the spending, right? So this opposite, right? So if this curve shift down, meaning there's a decrease in spending, and usually it's because you become pessimistic about future, right? As a matter of fact, so those are the cause. Okay. And this is what happens in reality. I mean, it's here, this is what happens in reality. So first, what are the causes? Either there's a change in expected future disposable income, or there's a change in aggregate wealth. What this means? So usually if you are expecting recession coming, and then so you was worried about, or you're expecting you have high chance to lose your job, your income is going to suffer. And then usually you're going to spend less. Does that make sense? On the other hand, so if there's collapse in housing market, if there's collapse in stock market, your wealth is going to decrease. You don't want to spend. Right? So these are the factors cause shift in the aggregate consumption. Now, if we look at history, it did happen. On the left graph, what do we have? Oh, by the way, so this number is refers to year. So for example, 33 means 1933. And here basically we just plot, what do we plot? We plot the 1930s. What happened in 1930, by the way, in the United States? Great Depression, right? So we first look at 1930, and then so we have this curve fits with the consumption. Again, this is another show or another proof of our consumption function is a good theory, right? Because if you look at like more than 10 years, so these things can fit with a straight line almost perfectly. Can you see that? Okay, now we move to the right-hand side. We are going to extend our data point. What do we do? So these dots in here, so essentially coming from here. And then so we have dots, which is post-World War II. And then you're going to see, if you read it carefully, there are two noticeable differences. The first one, this group of data move on, right? Furthermore, this group of data, if you feed with the consumption function, and then so you're going to see a curve is steeper. A steeper curve means you have a higher MPC. Does that make sense? Can you see that? Okay, to summarize, let me erase everything. If we comparing the time period of Great Depression with post-World War II, and for the US consumption function, we found out two things. Number one, MPC increase after Great Depression. Number two, the total consumption function increase. But this is very intuitive, right? What happened? What drive those two changes? We out of the wood, basically out of the Great Depression. We out of the World War II. So the expectation was good, right? So we are expecting a peaceful time and high growth, but actually that's what happened in history, right? So this expectation drives off consumption. Not only you spend more, and the proportion you spend more, right? So this is consumption function. Okay. Now we are going to look at another term, which is investment. Remember, let me just write down. So remember, so we have Y equal to C plus I plus G plus NX. For this chapter, we're going to focus on C and I. I'm going to explain so the rest in the future chapter. We have just look at C, and the next we are going to look at I. Okay, so I, in terms of absolute value, is much smaller compared to C. Like I said, C is almost 70% of the total GDP, and I usually is between like 10 to 20%. It's much smaller. Okay? Even though it is smaller, but doesn't mean it's not important. It is important, it's because, so this I is going to fluctuate quite a lot when the economy is in a up and down. This is given by this graph. So here we look at, let me see, 1, 2, 3, 4, 5, and 6 episodes. And what is common in these 6 episodes? Does anyone can see any similarity between these shows, between them? 1933 to 1935, 1980, 1981, 1983, 82, 1990 to 1991, 2001, 2007, 2009. Why would we put them together? What happened during those 6 episodes? Recession. Yes, actually, those are the 6 recessions US economy experienced. So in recession, there is a change in consumption and investment. Usually both decline, right? But by looking at the magnitude, percentage, you can see there's much more violent change in investment compared with consumption. Okay. But this is also very intuitive. Like, what is consumption? What is investment? Think about household. Consumption is your like a stable consumption, like basic food, say clothing. What is the investment for households? What is the investment? Like you buy a house, right? You buy a car, right? So when recession hits, when you losing a job, what are you gonna cut first? Food or house? It's obvious, usually house, right? So that's why investment is more volatile. And that's why even though it is small in terms of total spending, but it's powerful, and it's why we study. And similarly, so we are going to see, so what determines investment spending, or particular the change. Here we list the three things. Number one, interest rate. So why interest rate matters to investment? So essentially, that's the cost of investment, right? Think about the mortgage rate. Like currently, the mortgage rate should about almost 7%. And certainly, so your desire or incentive to purchase a house decline, right? Okay, this is interest rate. Second, expected future GDP. Why that matters? Because investment usually goes to capital, goes to the future production capacity. If you are expecting the future GDP is very strong, the demand is going to strong. And then you have incentive to expand your business by investing. Does it make sense? On the other hand, you are expecting recession is coming. Do you want to expand your business? Not really. There's no point, right? Because you know in the future the demands will weak. If you are a restaurant owner, you don't want to expand your capacity, right? So this is second. Third, kind of related to the second, current level of production capacity. If in the current, you can't utilize your capacity, do you want to invest or you don't? Just imagine you have a restaurant, you own a restaurant, okay? Most of the time, so the dine-in is probably like 50% or even less. Then the question is, do you want to expand or you don't? No, right? So that's kind of what this means. Current level of production capacity. If you are not able to function in full capacity, meaning the demand is weak, you don't want to invest, right? So this is similar to two, but this is about current, and the other one is about future, like expectation. But in either case, it just tells you the demand, how strong is demand, right? So those things matter to investment, okay? And particularly, this matters to plan investment spending. It's like, what are you going to plan? And what are you going to invest given the current situation, right? But there's also, okay, so I'm gonna skip this kind of, I already explained. So you, when the interest rate change and the investment is gonna change, right? Oh, by the way, so this following slides kind of just repeat or just kind of give you details of what I expect, right? So the first one, this one is about interest rate. And this one is about expected future real GDP. And the next one is wait, sorry. Oh, the next one didn't show up. So there are three things as we just as I just explained, right? Just keep that in mind. Now the last things is about the difference between investment or planned investment and unplanned investment. Okay. So first of all, what is planned investment? This is what you plan to carry out. That just depending on interest rate, depending on your expectations, depending on your current capacity. But in reality, there are unplanned inventory. And usually this happens because the reality is different from what you plan. Okay, and then usually if there's a difference, so for example, you invest a lot, you buy a lot of capitals, but the demand is weak. You're not going to destroy your capital, right? Just think about like iPhone, if they produce too much. And usually they're going to put in inventory. And we call them inventory investment. Right? If there's a change in inventory investment, and usually we call this unplanned, because this is just reality is different from what you plan. Okay, we call this unplanned inventory investment. So the plan plus unplanned, their sum is called the actual investment plan, investment spending. And the reason why we look at unplanned inventory investment is because that's going to serve as a signal to the move or to the direction of our economy. Okay, so we're going to pick up that in the next chapter. All right, so in the next chapter, we are going to see how the unplanned inventory investment is going to tell you the signal, to tell you the direction of our macroeconomy. All right, let me stop here for today. Thank you so much for your attention.